So my name's Devin Mitchum. I'm part of the Google Cloud Web3 team here, and that's a real pleasure to speak here today. So in 15 minutes, I'm going to explain some of the top themes that we're seeing in Web3. Maybe just a quick show of hands. Has anyone here been in the crypto space for the past maybe 10 years or so? Okay, I see a few hands. Okay, any hands here familiar with MEV? Okay, one or two. How about agents? Anyone here building with agents in Web3? Okay, great. Excellent context. So I'm going to cover today some of the themes we're seeing. Just a quick background. So in terms of Google Cloud Web3, we have decades of experience in the capital markets space. From our global network to the data-driven insights platforms that we have and AI tooling, as well as our Web3 division, where we've been building and partnering with some of the top foundations in this space. And what I'd like to really get into is, if anyone has their phones, we have a QR code here, but we recently launched the Google Cloud Web3 portal, where we outline some of the tools and services that we have in the space, and you can learn a little bit more in terms of some of the services that we offer. Now, the Google Cloud Web3 faucet is also something that we recently launched, where if anyone wants to get a drip from a popular protocol, you can go here, enter your Ethereum account or your Story IP address, and get a drip straight from Google. Now, some of the themes I want to cover today are across order flow and how it's really been evolving, especially the past year. There's some interesting trends here in terms of the infrastructure challenges that I'm going to walk us through. We're also seeing some trends when it comes to composable finance and really what this means for the world of intents, agents, and trusted execution. So let's talk about this, right? So we have a spectrum of markets. You have the world of, I think I have a laser pointer here. Yeah, so we have the world of regulated exchanges, right, where you have stock exchanges run by either national exchanges. You have settlement networks. These are all permissioned infrastructure running inside traditional co-location facilities. And then you also have the rise of permissioned exchanges. These are maybe centralized crypto exchanges or off-chain order books or off-chain L1s. And then these are typically built with enterprise-grade designs. Again, co-location facilities, with dedicated hardware really optimized and fine-tuned for settlement. But on the right, we have permissionless markets, and this is something entirely new. These are built on untrusted networks. They're decentralized, and they're often adversarial, where entities do not trust one another. And what I'm going to really get into in this talk is the bottom portion, where in the world of permission exchanges, you have incredibly fine-tuned hardware where settlement occurs, but in blockchains, settlement still occurs, even though there's a lot of economic warfare and a lot of adversarial actions happening on chain. Now, a traditional exchange typically designed like this: you have a common bus, you have matching engines, you have order books, you have pricing engines that all settle to this common multicast core for settlement. But in the world of public blockchains, well, these are actually built different. Okay, these are something that actually settle over different periods of time. Why is that? Because you have the crypto economic security and all the mechanisms that need to occur for these blockchains to settle and lock in that value. And popular chains like Bitcoin take around 10 minutes to settle every single block, 10 minutes. Where other chains like Ethereum, every 12 seconds you have a new block. Some of the more modern chains, Solana, Aptos, Sui, and others, these settle under 1 second. Now, zooming into Ethereum, I'm not going to read all this on the slide here, but Ethereum as a chain itself is quite interesting. It's optimized for diverse specializations in terms of this on-chain settlement. However, the block validation in terms of who builds those blocks, it's meant to be democratized and very simple, such that anybody can run a validator. And typically what this means is there's a wide diversity of the types of software you can run for these chains. There's different rise of order flow and block building, and this gets incredibly specialized, and there's a lot of interesting opportunities here. But this is something I'm going to dive into a little bit here, because from a cloud perspective, we work with a lot of partners to really optimize this order flow and block building task. And then the last part, when it comes to validators and economic security, This port, again, is something that we offer in terms of managed services, but also an area that's constantly evolving. Now, my next slide here is actually going to get into this challenge here. Does anyone here like memes? Okay, we got a couple meme lovers here. So this is a pretty popular meme from the Flashbots team where, let's see if this works. There we go. Okay, so with this meme is really explaining the concept in Ethereum where every 12 seconds a block is built. Within that 12 seconds, there's a lot of competition to get your transaction into the next Ethereum block. Okay, has anyone here tried a transaction on Ethereum, but then had it fail? I'm sure there's a few people who've had Ethereum transactions fail. Well, it does happen, right? And that might be because you're not paying gas, or you might not be routing your order to the right party. But there's a whole industry in this. This term is called MEV, and that's where people are competing to get their transaction into the block. Now, what does this look like? Here's the supply chain. On the left, you have users that submit transactions. It goes into this thing called the mempool, where all transactions sit and settle. And then transactions are pulled out of the mempool by people called searchers who pull out those transactions. Those searchers then send them to dedicated teams that build the Ethereum blocks. Okay, there's only one block built every 12 seconds, so everybody is competing to build that one block and win that one block. And then lastly, you have the validators that secure the chain and take the block. Now, what does this look like? This is a website called orderflow.art, if you want to check this out, by the team at Flashbots. This is actually quite interesting. This is order flow on the Ethereum blockchain over the past 30 days. On the left, these are all the user orders coming in. In the middle, these are all the people catching those orders and trying to replace those orders or settle those orders or front run or arbitrage those orders. And then you have your mempool where all these orders settle. And then you have the teams here on the right that actually build the blocks. Okay? But again, it's a supply chain from users, searchers, solvers, mempool, into the builders. Now, there's a lot of challenges here. Okay, and as Google Cloud, we're deep in these conversations, and we work with a lot of customers, and we have expert partners, if you're interested in this space, that can help solve in this area. But some of the challenges that we see when it comes to users is the simple act of doing a Ethereum transaction. Has anyone here performed an Ethereum transaction on a mobile app? Actually bought a coin? Okay. This is something where when you press buy, your order might be sent to one provider who then has to route your order to make sure that it gets into the block. Sometimes people actually have order flow where you can privately send your order in, and that person has a business relationship with a block builder to get that block built. Now, along the way, there's all sorts of challenges here from, again, the user routing their orders, getting them in. There's this the dark forest in the mempool, which is a place where all the orders are open so people can tamper with orders. And when it comes to searchers, these searchers are seeing all the orders come in, and they need to run real-time simulations, real-time insights every 12 seconds to find the best transaction. And then, of course, for builders, they're all competing to build the next block, the one block that will be selected. And this is a very competitive space where these builders are organizing transactions in certain orders to really optimize the best and build the best block. Why is that? Because these builders can pay a fee to the validator to get their block as the official next block in Ethereum. Okay, so there's a lot of things happening here. Now, zooming in very tightly just into the relationship between searchers and builders, this chart here is a 12-second chart. Okay, Ethereum builds blocks in 12-second increments. So as time moves on, all these blue dots are all the bids coming into the block builders, and the red dots are the blocks that get accepted by the builder. Now, I know there's a lot going on here, but generally what's happening is people will bid up the price to get their transaction into the block, and it always happens right around 10 to 12 seconds. Okay, so as Ethereum blocks come out every 12 seconds, everybody's bidding, bidding, bidding until the last second of the block, and then they'll spike the value through an auction into the block. it's a complicated space, but this is where a lot of teams are actually making quite a bit of money through arbitrage. A popular term here is the sandwich attack, where if you're buying an NFT, if you see that NFT transaction in the money in the memory pool, you can intercept that transaction. Okay. Now, for Google Web3, how do we solve for this? We have a lot of services. We have managed services, both for users, blockchain RPC. It's available now. It's free. You can go to our website. I have a QR code. We also have a managed service, the blockchain node engine, where you can actually run validators or run nodes managed by Google Cloud. And in the middle, we solve for a lot of teams with managed compute engine. We have AI tools. We have BigQuery with historical crypto data. And we have Kubernetes and confidential computing for teams that are building blocks or that are sequencing transactions. Okay, so that's a lot in terms of the main theme here in terms of order flow. Let me get into the next theme, which is composable finance. Now, composable finance is actually quite interesting, and it's mostly interesting for point number 3, which I'll get into, which is agents. But composable finance, to keep it very simple, is really around composable scarcity, okay? Now, we all know that Bitcoin, there's 21 million Bitcoins, okay? There's no more, there's no less. That's why Bitcoin has value. However, the Bitcoin price fluctuates, right, every day. It might be up 1%, might be down 5%, might be up 10%. That's not very stable. And if you're an AI agent, that's very difficult to program, right? Because as an AI agent or as a programmer, you want something stable. So we've seen the rise of real-world assets come out as stablecoins, and these are tokens pegged roughly to the US dollar. And just as of yesterday, the stablecoin market, you have around $215 billion in outstanding supply of stablecoins. Now, I'm not going to get into stablecoins in this talk. If you want to learn more, we actually have our AI portal that you can load, and here's a QR code. We have a Gemini-enabled portal on our website where you can ask it about stablecoins. You can ask about certain types of stablecoins. You can even find out maybe contract addresses for popular stablecoins. You can scan this to learn more. But what's interesting is the use cases that stablecoins unlock. And really where this gets into is when it comes to intents and agents and trusted execution. Now, stepping back a little bit, Web3 has really evolved. Okay, from the early days in Web3, 2015, 2016, most times that you would interact with a blockchain was through a command line, okay, or through an API. And this is back when things were much simpler. Okay, MEV was called miner extractable value. This is when Bitcoin miners or Ethereum miners for proof of work were all building that next block. But it was a very, I'd say the space was quite simple in terms of the type of sophistication you see on chain. And there were some agents back then, but really these were just trading bots. There's an open source bot called Hummingbot, which is quite popular, where you could run a computer and have it interact like with a Binance API to do your trading. Very simple, okay? Now, in 2022, things changed with Ethereum. And getting into the more broader space where order flow got more sophisticated, you had aggregators and you had proposer builder separation kick in. Now we're getting to this point where, again, now that you have stable coins and different primitives, you have a new form of agentic interactions that you can build upon. And two just quick buzzwords here. Agents, these are things where, again, it's software code that can run, that's characterized, that can pursue its own goals and be proactive. Okay, it's always living on chain. And then intents, you can tell an agent what you want to occur, okay, rather than how to achieve it. So instead of trading yourself, you can give it the intent, hey, buy 1 Ethereum at this price, by this date, and you lock it in a code. Now, let's face it, there are a spectrum of agents, okay, and you have to also be careful in this space. There's 2 types of agents, okay? One agent might actually be an intern somewhere. It's not truly an agent. It might be someone behind a computer screen. And there's other agents that are forming, and the term here is called trusted execution, okay? And at Google, we have something, the confidential compute platform, but these are spaces where through trusted execution, you can find different ways to find integrity, attestability to ensure that whatever code you're running is inside of a protected environment, and this is key. You want to get to a space where your agent is not a bad actor. And there's two big themes here in terms of TEs. I'm not going to go too deep here, but you can place smart contracts inside TEs and have a verifiable smart contract. You could even place AMMs or order books and place these inside the TEE computer chip itself and have dark pools. You can have snipe-resistant lending. And the last section here, you can also do block building inside TEs. If you're interested in this, you can check out Flashbot's BuilderNet. This is actually quite interesting, where they're building blocks inside of TEEs. For Google Cloud, we have confidential compute. We're ready, we'd be happy to talk to you if you're interested in the TE space. There's a lot of benefits this can provide. Here's the QR code if you want to learn more in terms of our platform. And if there's any questions, I'll be around after the talk. Thanks so much for the time.